How will you define a particle? Yes. Anyone? क्या होता है? Particle is an object. What else? जल्दी बोलो. Just an object. Particle, when we talk about particle, when we use the word particle, then we assume the particle to be very small in size. We consider the particle to be dot size or dimensionless. Do you think like this? Do you assume like this? Okay. So what is a particle? It is an object which has a negligible dimension. Just write the topic, write the term, and only write the keywords. No need to write the complete sentences. Okay. So we assume this object has negligible dimensions. It has no dimensions or negligible dimensions. Okay. And what is a rigid body? Rigid means, the word rigid means something which is hard, something which is fixed, or what else? Shape is fixed. It is incompressible. And if there is something which is incompressible, means there are particles. No? Everything is made up of matter. Matter is made up of particles, right? Everything is matter and matter is made up of particles. So interparticle distance cannot be changed. When we talk about a rigid body, we assume the body to be rigid, hard, stiff, shape cannot be changed, incompressible. If it is incompressible, means interparticle distance cannot be changed. This is what we assume. Yes. So a rigid body is a combination of particles. When an external force is applied, there will be no change in its dimensions. No change in its dimensions means its dimensions will not change. There will be no change in the dimensions if we apply the external force. Okay. Should I move to the next slide? So, are you a particle or a rigid body? This is a rigid body. See, if the relative distance between two objects is less, then they are considered as body. Relative distance is the distance between the two objects, we say. Okay. And if the relative distance is greater, then we consider that object as particle. Look at this aeroplane. Now we have a boy on the earth, and this boy is looking at the sky, watching this looking at this aeroplane. So this here in this particular case, relative distance is quite large between the boy and the aeroplane. Distance is quite large, so we can consider this boy as a particle. Okay. So if the relative distance is large, then objects are considered as particle, and if the relative distance is less, then objects are considered as body. Clear? So particle and rigid body are relative terms. Okay. The same boy, if the boy is standing with his mother, then relative distance is less. In that case, we will consider the boy as a body. But if this boy is looking at the sky, at the aeroplane, then we'll consider the boy as particle, because relative distance is large. So these are relative terms. It depends upon the condition. Okay. Rest and motion. These are the two states of motion, we say. If the object is at rest, then its state of motion is rest. And if the object is moving, then its state of motion is motion. And state of rest is the state of motion with zero speed. If the object is not moving at all, means it has zero speed, and its state of motion is rest. Okay. Karthik, so what is rest? no motion at all, object is not moving at all, then we say it is at rest. If the position is not changing with respect to time, then it is at rest. So we have different objects, these are at rest. Okay, so if a body does not change its position with respect to surroundings, then the body is said to be at rest. Only write the keywords. Should I move to the next slide? And what is motion? If the object is moving, how do we know whether the object is moving or not? How do we know? We observe the object and we see that, yes, it is covering some distance, so it is moving. Yes. So moving blades of a fan, moving car. So these are the examples of motion where you can see the object is changing position with respect to time. We have passengers in the bus and they are moving in forward direction. Now you tell me, are these passengers in the bus are at rest or in motion? Yes. Both. शाबाश. Expected. नहीं नहीं बिल्कुल ठीक बोल रहा है लड़का हमारा. ठीक है. So passengers in the bus are moving with respect to the people who are standing outside on the bus stand. ठीक है. So people who are standing outside in the bus stand, for them, passengers in the bus are moving in forward direction. But if we look at the passengers only, then two passengers are at rest with respect to each other because their relative distance is the same. Yes. Passengers in the bus are at rest relative to each other, and passengers in the bus are in motion related to the people who are standing waiting for the bus at the bus stop. Okay, for them, they are moving in forward direction. And for the passengers who are sitting in the bus, for them, people who are standing at the bus stand, they are moving in backward direction. Okay. So passengers are at rest with respect to each other. People who are standing at the bus stand, they are also at rest with respect to each other. But for the people who are standing there at the bus stop, passengers are moving in forward direction. And for the passengers, those people who are standing at the bus stop, they are moving in backward direction because the relative distance is increasing, changing. Yes. So what is rest? Rest तो कुछ भी नहीं है फिर इसका मतलब कोई भी रेस्ट पे नहीं था. It depends upon the observer. Yes. So we can say that nothing is in absolute rest or in absolute motion. An object may be at rest in one situation. ठीक है, मतलब अगर कोई भी situation आप consider कर रहे हो, so we can consider the object at rest or in motion at the same time. It depends upon the frame of reference we are choosing. ठीक है. So a body is said to be at rest when there is no change in position with respect to time. And on the other hand, if there is a change in position with respect to time, then the body is said to be in motion. Okay. So the branch of mechanics that deals with the study of motion of objects without any reference to the cause of motion is called kinematics. See, here we are studying kinematics. We will not consider the cause of motion. Here, cause of motion is usually the force that we exert on an object to make it move. Okay. So we are not considering here the cause of motion. We are not considering here any kind of force. So it is kinematics. But when we include force, then it becomes dynamics. When we consider motion of the objects and include the cause of motion as well. Cause of motion is the force that causes motion, then it becomes dynamics. So these two chapters, motion in a straight line and motion in a plane, they come under kinematics. See, as we have different branches of science, physics, chemistry, and biology, In the same way, we have different branches of physics, mechanics, yes, thermodynamics, electromagnetism, optics. So in mechanics, we study the motion of objects. So if we are considering motion of objects and we are not studying the cause producing the motion, then it is called kinematics. Kinematics is a branch of mechanics, and mechanics is a branch of physics, and physics is a branch of science. So in science, we have physics. In physics, we have mechanics. Your first 7-8 chapters are of mechanics. And in mechanics, we have different branches, sub-branches. So one of the sub-branches is kinematics, where we do not consider the cause of motion, where we do not consider the force which causes the motion. Okay. And a system of coordinate axis with respect to which an event can be described is called frame of reference. So frame of reference can be anything. We can choose frame of reference as per our convenience. You can choose frame of reference apne aap ko bhi, yourself as well. I can consider myself as frame of reference. If I am the frame of reference, then I will find the relative distance of all the students who are sitting here with respect to me. Okay, because I am the frame of reference. So frame of reference can be addressed. You can choose a moving reference frame as well. You can choose a frame of reference which is at rest. Any frame of reference can be chosen. See, rest and motion are relative terms. Relative means motion is a relative term. कैसे explain करोगे इसको? अभी we have just discussed. Are you all at rest? You are sitting on your chairs. You are at rest because relative distances between you and me and all my students is not changing. So all the students are rest with respect to me. But if I am observing you all from the surface of moon, then are you rest pe ho ya motion pe ho? Motion pe ho. Kyun ho motion pe? Because earth is rotating about its axis and you are also moving along with the earth. So you all are in motion in that case. Okay, so motion and rest are relative terms. It depends upon the object and the observer. Observer and the object under study. The motion of an object is always with respect to some reference frame. Okay. For example, as we have chosen, we've taken this example now. So we can consider people who are standing at the bus stand as one frame of reference. From their perspective, from their frame of reference, bus is moving in forward direction and all the passengers are also moving along the same path. But if we choose bus as a frame of reference, then people who are standing at the bus stop, they are moving in backward direction because the relative distance is increasing. So bus is another frame of reference and people who are standing at the bus stop is one frame of reference. So our frame of reference can be at, we can choose our frame of reference to be at rest or in motion. Okay. Frame of reference आपका rest पे भी हो सकता है. Frame of reference आपका moving भी हो सकता है. यहाँ तक कोई doubt? Good. Let's see how the states of motion and rest are related. Rest and motion are relative terms. They are not absolute. We say that nothing is in absolute rest or in absolute motion. हम ये नहीं बोल सकते कि कोई भी चीज absolutely rest पे या absolutely motion में है. एक object rest पे हो सकता है किसी frame of reference के respect में और किसी दूसरे frame of reference के respect में वो moving हो सकता है. So a body can be at rest or in motion with respect to frame of reference. A body can be at rest or in motion at the same time and depends upon the frame of reference that we are choosing. And there is no frame of reference which is perfectly at rest. Okay. A man in a moving train is at rest with respect to co-passengers. Yes. But he is in motion with respect to a man outside the train. If a man is standing on the platform outside the train, and for him, all the passengers are moving in forward direction, right? But passengers, they are at rest with respect to each other. Clear? A particle is an object having negligible. What is the answer? Dimensions is the correct answer. Next question. Rigid body is a combination of particle. When external force is applied, there will be no change in its. रिजिड बॉडी में पार्टिकल्स होते हैं, अगर हम एक्सटर्नल फोर्स अप्लाई करेंगे तो उसकी डायमेंशंस में चेंज नहीं. रेस्ट एंड मोशन आर relative terms and not absolute. Rest and motion are not absolute. Yes, both B and C is the correct answer. Next, we have types of motion. So there are different types of motion. If the object is moving in a straight line, then motion is in straight line. That's called rectilinear motion or translatory motion. If an object is moving in a circle, then it is circular motion. And when the object moves in a circle, then it moves about a fixed point. About a fixed point. सर्कल में ऐसे मूव करता है, ऐसे मूव करता है. किस पॉइंट के अबाउट मूव कर रहा है पार्टिकल? दिस इज द पार्टिकल, दिस फिंगर इज द पार्टिकल, इट इज मूविंग अबाउट द फिक्स पॉइंट. फिक्स पॉइंट इज द, दिस इज द फिक्स पॉइंट ना. दिस जॉइंट, आई एम मूविंग माय आर्म ना, लाइक इन सर्कल. So what is the fixed point here? This joint is the fixed point, and this fixed point is the, this is the radius. Arm length is the radius, and this fixed point is the center. So when the object moves in a circle, it moves about a fixed point, and the fixed point is the center of the circle. This is circular motion. And what is rotational motion? Is there any difference? Is there any difference between circular motion and rotational motion? Do you find any difference? तो सेम ही होते हैं, अलग अलग नाम दे दिए बस. अलग होते हैं शायद. What is the difference between rotational motion and circular motion? Look at this. We are rotating this marker, and this marker is rotating about an axis. And this axis about which this marker is rotating, it lies within the marker. It passes through the center of the marker. है ना? यहाँ से स्टिक लगा लोगे, ऐसे पकड़ लोगे तो ऐसे से घुमा सकते हो ना इसको. This is rotational motion. So all the particles, how many particles we can assume lie on this marker? How many particles are present in a line? How many points are present in a line? Infinite. Points is the word. Infinite points. है ना? And how many points will lie in the marker? So if we assume this marker to be made up of points, we have infinite number of points, and all the points are moving in different circles. All the points are moving in circles of different radii in a particle. If this is solid, so जो अंदर वाले particles हैं, they have the smaller value of radius, और जो outer particles हैं उनका bigger value होगा radius का, and all these particles are moving with different radius about this axis. So this kind of motion is rotational motion. क्या समझ आया? Got it. Either 100%, 90%. Okay, next is oscillatory motion. This is oscillatory motion. To and fro. And this is the extreme position. This is the mean position. Extreme, mean, another extreme, back to mean. And how do we calculate oscillations? How do we count oscillation? Huh? One oscillation is mean to extreme to another extreme and back to mean. Mean to extreme to another extreme and back to mean is one oscillation. Okay. What is vibratory motion? What is the difference between vibration and oscillation? Not a difficult question. 11th class के बच्चों पे कौन पूछता है? अर्थक्वेक में वाइब्रेशन होता है, ठीक है, वो ऑसिलेशन नहीं है? अच्छा, बहुत डिफिकल्ट क्वेश्चन है 11th क्लास के लिए ना. दिस इज वाइब्रेशन. लग रहा था आपको डिफिकल्ट क्वेश्चन पूछ लिया. मुझे भी लग रहा है मैंने गलत पूछ लिया, ये नहीं पूछना चाहिए था मुझे. चलो कोई बात नहीं, सीख लो, कोई बात नहीं, क्या कर सकते. ये क्या है? क्या ये ऑसिलेशन जैसा नहीं लग रहा? नहीं लग रहा?
मैंने बोला था ऑसिलेशन जैसा होता है.
ऑसिलेशन जैसा होता है. ये स्मॉल ऑसिलेशंस, स्मॉल ऑसिलेशंस, वाइब्रेशंस. ठीक है. The crawling ends, you can see they are moving in a same straight line. So this kind of motion is okay, so this kind of motion is motion in a straight line. Okay. And cockroach moving on a floor. Let it move. Cockroach moving on a floor. This kind of motion, see here is going like this. So we need two coordinates to specify its location at a particular point of time. So this kind of motion is motion in a plane. Yes. And we have honeybee. Question ये नहीं होना चाहिए. अच्छा, अब ये honeybee है, तो honeybee के केस में what kind of motion is this? See, it's moving in three-dimensional space, na? So this is motion in a space. Motion in space. So what type of motion is this? Motion in a space. Honeybee can move in all, three directions. X, Y, and Z axis. कहीं पे भी जा सकती है, right? So it's motion in a space. Types of motion. Motion in one dimension is this. Straight line. Motion in a straight line, and motion in two dimensions is this. Motion in a plane is three dimensional. Any doubt? Motion in a space is three dimensional. So how many types of motions are there? Three. Motion in one dimension is also called. One dimension is called motion in a straight line. Good. Rectilinear motion is the motion in straight line or what? Recti, the word recti, and we have two words here, recti and linear. इसको संधि विच्छेद कर दो, इसको हिंदी आती है. ठीक है.
बहुत छोटा चैप्टर, सेकंड चैप्टर कर रहा ना.
हाँ छोटा. So recti means straight and linear means line. So when the object moves in a straight line, then it is called rectilinear motion. Motion along a straight line. For example, motion of a car on a road. When a car moves on the road, moves in a straight line, so it is a rectilinear motion. Example of rectilinear motion. Yes. See, rectilinear motion need not be one-dimensional necessarily. Rectilinear motion can be any straight line in any direction. Okay, any straight line in any direction. But it is always possible that rectilinear motion can be treated as one-dimensional motion. See this example, we have a car here. We have two reference frames. In one reference frame, we have chosen the normal reference frame that we take usually, and another reference frame, another coordinate axis that we have taken is tilted. Okay. So rotation of coordinate system does not change the rectilinear motion of the car. It is still rectilinear motion because any straight line motion can be considered as a rectilinear motion. So we know what scalar quantities are. which have only magnitude but no direction are called scalar quantities. This we have discussed already. Yes, for example, speed, distance, and mass, temperature, work. These are all scalar quantities where we need just magnitude, no direction is needed. While on the other hand, vector quantities are those where both the magnitude and directions are needed. And yes, displacement, velocity, acceleration, force, weight. So all these quantities are vector quantities where these are defined by both the magnitude as well as direction. But one more thing to be added. These quantities should follow laws of vector addition. Okay, they should be added by laws of vector addition only. If a quantity has direction, but it does not follow the law of vector addition, then that quantity is not considered as a vector quantity. That is a scalar quantity. For example, current. Electric current is a scalar quantity, though it has both the magnitude as well as direction. Then why do we consider current as a scalar quantity? Because it does not follow the laws of vector addition. Okay? Clear? Next topic, path length and displacement. Path length means length of the path traversed by an object. Length of the path or actual length of the path traversed by an object is the distance traveled by the object. Actual distance. And displacement, displacement. It is made up of two words. दोबारा संधि विच्छेद कर दो. ठीक है? Displacement. Displace, out of place. ठीक है? Out of place. अगर कोई ऑब्जेक्ट डिस्प्लेस हो गया अपने पोजीशन से, ठीक है, तो कितना डिस्प्लेस हुआ? There we consider initial and final positions of the object. We do not consider the path traversed by an object. We only consider the position where the object was and the position where the object is now. Okay. So path length is the total distance traveled by an object from its initial to final position, and displacement is the shortest distance. The straight line distance is the shortest distance. If we draw a straight line between initial and final positions, then we get the displacement. Okay, this you have done in class 9 as well. Suppose let's consider a situation where we have 3 different locations, home, college, and McDonald's, and you travel from home to college and then you go to McD. Okay, so what is the distance covered by the object? Home to college. You will add the distance, simply add the distance between home and college and McD, you'll get the path length. Okay, path length is distance between home and college plus between college and McDonald's. And what is the displacement? Initial position is home, final position is McDonald's. So what is the displacement? Shortest distance between initial and final position is home to McDonald's distance. That is displacement. When is distance and displacement equal? When the object moves in a straight line. So for this, we can consider this situation. We start from our initial position, go to the McD. So this is a straight line distance, and straight line distance is the shortest distance. So both the path length and displacement are equal. Okay, so when the object moves in a straight line, then path length and displacement, they are equal. And clear? Any doubt in this? Easy here. So path length is never zero, but displacement can be zero. For this, again, we can consider the same situation, but this time,
home से McDonald's जाके McDonald's से वापस
yes, home से McDonald's जाके वापस आ गए घर. ठीक है? So what initial position and final position both are coinciding. It's home. Displacement is zero, but distance is not zero. The path length is, you will just double the distance and displacement is 0. Okay. So when initial position and final position coincide, then displacement is 0. Because object is not displaced at all from its initial position. Okay. You're not writing. Writing. देखते नहीं हो लिखते कहाँ लिखते हो magnitude of displacement may or may not be equal to the path length traveled by an object. Equal भी हो सकता है और equal नहीं भी हो सकता है. Equal कब होता है? When the object moves in a straight line. And in other cases, path length is always greater than displacement. This is the only case where path length and displacement are equal when the object moves in a straight line. But if the object is not moving in a straight line, then path length is greater. The magnitude of the displacement for a complete motion may be 0, but the corresponding path length is not 0. For a complete motion means जो भी situation आपने consider किया उसमें जो displacement है वो 0 हो सकता है. कब होगा? जब initial और final position coincide करेंगे लेकिन corresponding path length is not 0. Correct statement among the following is when displacement is 0, distance traveled is not 0. When displacement is 0, distance traveled is also 0. When displacement is 0, distance is 0, displacement is not 0. Distance traveled and displacement are always equal. Which statement is correct?
First.
Next, the numerical ratio of displacement to distance is yes, maybe less than or equal to 1. Distance and displacement are equal when the object moves in a straight line, and in other cases, displacement is always smaller than distance. The total distance traveled by an object from initial to final position is known as path length. Beta, total distance traveled. Total distance traveled. Path length. Next topic is uniform motion. What is uniform motion?
Straight line.
No.
Speed होता है.
Speed uniform. हाँ क्या हाँ
intensity और time मतलब चलता रहता है. Speed constant रहेगी आपको, ये change नहीं होगी.
So what is uniform motion? If an object is moving along a straight line, covers equal distances, equal intervals of time, however small these intervals may be, it is said to be in uniform motion along a straight line. So for this, we have considered a situation where the car is covering a distance of 10 meters in every 1 second. Okay. So after 1 second, car covers a distance of 10 meters. If we consider the first case here, look at the cursor movement. What is the speed in this time interval? It's 10 meters per second. In the next time interval, again, it is the same 10 meters per second. In the third time interval, it is still the same 10 meters per second. So every time we can see object is covering equal distance in equal intervals of time. So when the object covers equal distance in equal intervals of time, then its speed is constant. Yes, object moves with uniform speed. Okay. What is speed? Rate at which an object covers distance or distance upon time. It is a scalar quantity. Speed is path length upon time taken. And what is velocity? Displacement upon time, or we can say rate at which an object changes its position in a given direction. And velocity is a vector quantity. Or we write the formula for velocity as displacement upon time taken. Please write the formulas. You're writing? Should I move to the next slide? Examples. Let's take examples of speed and velocity. Again, we'll consider the same situation, home and McD. So we are just riding bicycle from home and going to McDonald's and coming. Then during the total journey, let's take distance between home and McDonald's be 2 kilometers and time for the whole journey for the complete motion is 1 hour. In 1 hour, we just come back home. In 1. We are slow.
Home to McDonald's.
1 hour में आ गए.
मैकडॉनल्ड का है ना बस 1 घंटे में एक ही साइड कवर है
नहीं दो. So what is the path length? Path length is 4 kilometers and time is 1 hour. Displacement
जीरो
y 0.
इनिशियल और फाइनल
Initial and final are coinciding. So we can find speed as path length upon time. We'll put the values of path length and time. We'll get the speed and velocity. Displacement upon time because displacement is 0 and so is the velocity. Easy, simple question. Speed is a scalar quantity. Velocity is a vector quantity.